Section 3.8, the vibrational analogy. So we're looking at this SF6, sulfur hexafluoride, with a OH point group. And then if we're looking at the vibrations of the 6 bonds, there are 6 of them. So this one is completely symmetrical. This one involves only 2 bonds. Similarly, only 2 bonds are vibrating. Same here, 2 bonds are vibrating. Now over here, 6 bonds are all vibrating in a concerted manner. However, in this direction, the vibration is more intense. And over here, okay, you have the 4 bonds on the XY plane doing vibration. So they actually correspond to the molecular orbitals. And this corresponds to the s orbital of this sulfur interacting with the 6 fluorine atoms. It's totally symmetrical. These 3 correspond to the px, py, or pz orbitals on sulfur interacting with only 2 chlorine atoms at one time. So let's say this is the x direction. The 2px orbital of sulfur is interacting with these 2 fluorine atoms only. Let's say this is the y direction. Same here. We have py of sulfur interacting with 2 fluorine atoms. Pz, only 2 fluorine atoms are interacting with this s orbital. So again, this px, py, pz from sulfur are interacting with only 2 fluorine atoms, and they have a symmetry of T1U. U means ungerade in German. That means anti-symmetric with respect to the inversion center. So you know px, py, and pz are anti-symmetric with respect to the inversion center. Now E stands for a degeneracy of 2, so these 2 have the same energy, and over here this actually corresponds to the dz squared orbital of this sulfur interacting with fluorine atoms. And over here it's dx squared minus y squared. So this is the x direction, this is y direction, and this is the z direction. So again, let's look at the symmetry here. The subscript says G, that means, well, symmetric with respect to the inversion center. So if you look at dz squared and dx squared minus y squared, you will see they both are symmetric with respect to the inversion center. So just one more thing, if you take quantum mechanics, you will see this wave function is proportional to x squared minus y squared. This one is actually proportional to either 3z squared minus r squared or 2z squared minus x squared minus y squared. So if you think about it, it's 2z squared minus x squared minus y squared. You'll see, a little bit more contribution from the z direction, a little bit less from the x direction or y direction compared to the z direction.